Good afternoon. Thanks for coming to the last session, but one, I think. It's always hard to be the last. So um, I know this title or this session was titled Vendor Perspectives, and I'll get to that eventually. But first of all, I just want to talk about what we did actually contribute, which was the layer 2. It ended up being the layer 2 monitoring in ECORD. So like Mark said, we started out in January, and it's probably even last November, even I think a year ago, that we started looking at ONUS. It's an interesting platform, and in fact, I must say I find it addictive myself. I can't stop playing with it, and that's how we actually have something to show for it at the end of the day. So. So basically, what this is about is basically an application in ONUS, which through the division of Mark and Andrea, they've integrated it into ECORD, and basically it acts as a layer 2 monitoring solution in ECORD and allows services to be monitored from end to end for enterprise customers. So it's a short enough presentation, 5 main points here. What is layer 2 monitoring, and why do we apply it to ECORD? And I have a slide in there about the relationship to ECORD, and that's future possibilities. What device supports this, and then I get on to the vendor perspectives, which some people might be interested in. So quickly, I'll just brush over this. So this is a standard that's well established. It's 802.1q. So there's this CFM is a standard there for connectivity fault monitoring, and it sits on top of services effectively. Carrier Ethernet services are differentiated, E-lines are differentiated by VLANs, and that's what this monitoring is doing. There's standardized tests, loopback, link trace, CCMs, and I don't know, many of you may know about MEPs. They're a layer 2 monitoring endpoint effectively, and basically we modeled all of this in ONUS through an API. So effectively, bringing it back to the ECORD situation, this may be a card pod in one customer premises, and you may have another one over at this side. And basically, what this allows you to do is define a logical entity called a maintenance domain that spans across between the card pods, and to monitor it and run all of those tests and examine what's going on. So extending that then is what's called SOAM, Services O&M, and basically this has been defined by MEF as an extension to MEF Carrier Ethernet services. So this is something that builds on top of CFM, and there's the concepts of E-line, E3, E-axis. Basically a MEP sits at each one of those points, and you can have like a monitoring network set up between all of those. Now, let me see, how is it applied to ECORD? So basically, ECORD is based around carrier Ethernet services, and basically, what we've done is we've added in this functionality into ONUS as an API. There's a REST northbound interface as well, and basically there's a set of behaviors which are interfaces that drivers can say they implement. So this kind of thing is not currently running on white box switches. This is basically hardware-based monitoring for services. There are other kinds of monitoring possible in CORD, and one of the things that is being looked at in ONUS is INT. I can't remember what the acronym stands for.
Independent network telemetry.
Right. Okay. So this is another way of looking at monitoring of packets going through a network. This is a one that particularly INT is another alternative, and there was another talk this morning by the Performance Brigade about how they're measuring latency and jitter to try and improve performance in the platform as well. So there's many different forms of monitoring can go on inside a platform like ONUS. This is another one, is what I'd like to say. So in this circumstance, or in this ECORD, I suppose, installation, it manages this carrier Ethernet services, and as they're set up, adds monitoring on top of them. And I suppose one of the next things I wanted to talk to was about, well, ECORD, and I'll cover that in the next slide. This is just a repeat of a slide Mark had earlier, I think, showing where the pod sits, and this is a CPE here that might implement this monitoring. Any one of those, could act as a monitoring point internally inside the network as well. Maybe there will be in a future extended implementation of this, but basically at the moment it's really in the CPE at the end, and of course at each different pod. So inside ONUS, this is basically just a capture of the Java doc for the API, and if you're looking for it, it's under Incubator Net Layer 2 monitoring, and there's a whole set of Java doc there, and really the API has been transposed from a carrier Ethernet standard, the MEF 38 and 39, and for the REST API, there's a Swagger documentation for it, which is coming soon in a new patch. So basically, really inside ONUS, it's pretty simple. There's these behaviors. So the MEF programmable says the device supports creating MEPs, and the SOAM DM programmable says this device supports delay measurements, and LM is this device supports loss measurements. So basically, there's a set of services inside ONUS in the middle, and then there's the northbound REST API, and there's a CLI there as well for managing and monitoring these things. So this is what the end result looks like, and as Mark showed earlier, they've done an extension to the XOS GUI to pull back these kind of statistics, and what it's showing here is these are periods of 1 minute, and over a 5-minute period here, this is showing delay and jitter. So this represents really the history view, and I don't know, the legend here is showing that that's the jitter average. This is the delay average, and so on like this. So there's a downward slope, and in the delay and jitter are reducing at the later time in this particular graph. That's the history view, and then there's the current view, and the current view is being calculated on the device, and so these KPIs are being sort of binned, and there's time bins. All of the delay here in this particular circumstance was between 0 and 10 milliseconds, and the jitter was all of the recorded instances were between 0 and 3 milliseconds. So this is built into the XOS GUI as it communicates with the device that's doing this monitoring. So this just a couple of slides about ECORD, and ECORD is analytics for CORD. This is kind of not my slide. It's taken from the ECORD thing, but basically, you have your ECORD and your MCORD and the RCORD, and they're all being probed effectively. That the idea is that each one would have a probe, and I guess that's where this monitoring work is going, that it eventually will become a probe in ECORD that can be fed up into ACORD, where analytics can be applied to it, and I think an extension of that in the roadmap for ACORD is that basically this would lead to closed loop control. So basically, you'd have the analytic engine. It's driving some kind of monitoring as a service, which is configuring. the probes and querying the probes and gathering that back, and somewhere inside the analytics engine taking action up on the monitoring that's going on. If there's a particular high level of jitter, we'll say, on one particular circuit, switch it to a different circuit. And it's kind of closed loop control, where in future, I would hope that something like this monitoring API could be used to lead to this kind of functionality. Now, just to a caveat on that, ECORD is currently only being ported to CORD 4.0, and this CFM and SOM exist independently of ECORD. I put it in really just to show you what the goal could be in the longer term, and where this work is going. So in terms of device support, this is a device that we developed in Microsemi. It's an SFP, and it's an active SFP that acts as a NID. So there's an FPGA and a processor in there, and basically it's capable of doing all of those kind of things like delay measurement, loss measurement, loopback, link trace, CFM, all of those kind of things. So what I did to support ONUS is I wrote a driver for ONUS, and on the advice of the guys here, we made it. We made the behaviors to expose the CFM functionality. We made them into behaviors in ONUS. So basically, any vendor could come along and implement these behaviors. So any NID vendor could come along and build a driver quite like ours, and they would automatically work with ECORD. So I think it's a very open model, and it's a very extensible model. It's something we were happy to participate in. There's a benefit to being the first in. You can make sure your device works with the ecosystem, and I think this was a motivating factor for us. Like this is a device that's not an open flow device per se. It's everything in it is configured through netconf, but with a little bit of work and fiddling with the netconf, we made it into a device that practically acts like an open flow switch. It can support flows as long as there may be VLAN push and VLAN pop and things like this, and also with these behaviors, we've extended them then to translate the behaviors into netconf config, and now it goes down and configures the device and returns values, all done through netconf. So there's a lot you can do when you follow the kind of well-structured design and layout of ONUS. So this is where I get on to the vendor perspective bit, and basically, I suppose I just wanted to explain where we're coming from in terms of ONUS. Obviously, ONUS and ECORD are obviously operator. It's an operator-led consortium, and most of the people who are sponsoring it and interested in it are operators. We've seen the big ones, DT and Telecom Italia and China Mobile, etc. And I think there's you'd have to say there's really, I suppose, reluctant support from traditional box vendors. Okay, I think ECORD or CORD and ONUS both represent a disruptor in the network industry. And I think the word disaggregation sometimes can strike fear into the heart of product managers that are selling big boxes and have done so for the past 20 years. So I think we're seeing a paradigm shift in the industry, and the management plane of these boxes is now wide open. Whereas, for years there has been an industry built around the protocols of keeping well, I suppose of making sure boxes work together. Now that problem has gone away. If the control or the management plane is wide open. So, like, if you look at the subject of EMSs, and I've worked a long time in the industry. I used to work in Motorola building EMSs for mobile equipment, and the same thing was gone through again and again. We built these EMSs. There was always the integration tax from an operator's point of view, and then they'd see a new piece of equipment, and what are we going to do with this? How do we get this to work with all of our other equipment? And the only answer really was put more and more people managing the thing, and that's kind of you ended up with a very sort of locked in sort of mode of operation, then that every new piece of equipment was extra work for people to do. And because of that, then you had vendor consolidation, that look, we don't want to take anything new from this company, because like we'd have to learn all about their EMS and integrate it, and actually it consolidated the lead of the big box vendors, I think, even a bit more. And shoved out smaller ones. So anyway, look, this I think is going to change, and really the operators are driving it, and I think part of the reason is the big internet vendors. The likes of big operators are looking at the likes of Google and Facebook and Microsoft, and seeing like how can they manage so many machines, so many services, have such redundancy with them. It's because everything is automated, and I think this is where the industry wants to go. It wants to get more dynamic with its services, and it wants to get more into control of devices in response to customer requests, rather than configuring something and expecting it to stay that way for life, or for long periods of time. So I think, if you look at ECORD and CORD in general, I think because it's an operator-led consortium, I think what's happening here is they represent the user defining the use cases. Okay, they represent the operators such as DT or AT&T defining the use cases and saying, like, what do we really want to do here? We want configurable services. We want enterprises to be able to come in and configure services themselves without and not for it to take months. So this is the use cases, rather than the vendor defining what they think is. That should be what they think is best for the operator. Okay. So I think that represents a sea change in itself. And I shouldn't say expect pushback here, but I'd say expect to be kind of undermined, I think quietly, rather than an explicit pushback on ECORD or any card. So like, just considering this EA1000 device that we developed, right? So we could have gone off and built an EMS to manage this with, and said to everybody, yeah, well, you've got to install this EMS, and then you configure this device, and it seems so alien and unrelated to the kind of speed of things that are happening in CORD and ONUS, where everything is configurable immediately and dynamically, and the whole system is open, and the kind of functionality that's in CORD as well is something that we find hard to build ourselves, just to manage one little device, because it's a useful device, there's no doubt, but it's only as good as the ecosystem it becomes our part of. So just on the subject of EMSs, vendors, and this goes back 10, 15 years. I think EMSs came along, and they're definitely a necessary part of producing a product such as a box. But vendors generally can't ever figure out which they make their money from. Is it from selling EMSs, or is it from selling boxes, right? EMS is, it's software. You build it once, you sell it many times. Whereas like a box, you've got a fixed cost with it every time. Generally, it's priced just enough to pay for development. You can't live without it, obviously. It's strategically important to have, a holistic system that you can put a device in, it works, and it works. A cluster of them can work together, or they work in some sort of holistic way. But like, it's still an outsider. The EMS is still an outsider when it comes into a customer's network. It's got to be managed. Somebody's got to be trained on it. It's got to be installed. It's got to be, all of these kind of things. And they do take years to develop. And really, all it's achieving is the same old FCAPs over again. Default configuration, accounting, performance. This kind of thing. So I mean, looking at looking at CORD and what it does, taking a device like EA1000 allows you to say, look, the business case is already established for putting ECORD in there. Okay, we heard it from I think Telefonica the other day, that they said, there's a very green, there was a green for go on the business case for implementing CORD inside their business, right? And now they're getting in CORD. If a device has native support for CORD, it becomes an obvious case that that now we can see how it fits into our business. But from the perspective of the product manager inside, say, a company, a vendor company, they're looking at this product and they're saying, okay, we know CORD is there, we know it's in the customer network, but it's not in every customer network. So what do we do now? We still need to manage the thing, right? What about customers that don't use ONUS or CORD? Do we have to build a driver for every ecosystem out there, or open source system out there? Or do we go off and we build an EMS for all of those systems anyway, right? So, I mean, another way of looking at it is CORD and ONUS are completely open source, right? So anything in CORD and ONUS can be reused and deployed and distributed. So, for instance, rather than building an EMS, an alternative would be you can package up your driver that you've written for CORD or ONUS and gather together the open source components for it, and make make a front end on it or something like this, or and package it up as a solution for those other customers. So what I'm saying here is really, I think from my perspective, it's time to move on from EMSs and basically consider the bigger picture, and the fact that there are big disruptors coming into the networking landscape, and I think there are ways to work with them rather than sticking your head in the sand and hoping it'll all go away and they'll they'll all be coming back to you looking for your EMS and your devices eventually. I think the industry is changing, and this is kind of what I'm getting at here. I think that's the last slide. So just to summarize, Layer 2 monitoring is a feature that we delivered to CORD, and we think it has a bright future. It's something we delivered because our device supports it today, and that's that's a big advantage, is to have a device that can hit the ground running. I think CORD is a game changer in the telecoms industry, and I think the kind of new industry supported open source platforms, and this goes for everything, even like OCP or any one of those, ONAP, any one of those, they do require a rethink of existing software systems. That's it. That's all I have. Any questions? No questions? Okay. All right. Well, thank you for listening.